Your HVAC problems may have been there since the house was built and you never knew. Today, we're going to be talking about the top 7 construction issues created before your house was built. All right, welcome to ProCalcs University. This is Tom Platania, your host. And I think I'm really starting to enjoy these videos. You know, it takes a little chunk out of the day to get them all created. And, well, it doesn't take as much time for me as it does for poor Marie to edit and clean these up with all my hack and slash. But she's doing an amazing job. So we want to give our big hand to Marie for doing all this. You know, we're having fun with these. We're learning some new things that we've done. I know we might have talked about it briefly in the last video, but from one of our listeners, viewers, suggested that, because we talk about only a little bit of what the issue could be, because we don't have a lot of time. Somebody doesn't want to sit here hours watching a YouTube video. I mean, unless it's something really, really specific. But we find that the shorter videos really help for the general public. But for those of you who want more in-depth information on the topic, what we are doing is we are going to be creating a little short book for every single solitary video we're going to be doing. Now, we're trying to get them caught back up for the ones we've already done. But what these books are going to do is go into a lot more detail, if you want, about the topic that we discussed. Now, there's a small fee. I mean, they're going to range from $1.99 to $2.99. Nothing big. I want to keep them cost effective. I want to add some value. I'm not making look a ton of money off of it. Just want to be able to give you some additional information that you may not have gotten from the video. And also, you know, in the comments below, when you get these books and you read them, if you feel that they need more detail, I'm trying not to make them too long. You know, keeping them under 20 pages, you know, in small format, 20 pages, not big legal size. But we're trying to add that value so that, you know, some people want to look at them. So let us know in the comments below if you get a book, what you think about the book, or what do you think about the concept, if you think it's a good thing. So, all right, so let's get to our hat challenge. Now, got another hat on today. Now, technically, when I'm doing this video, it's actually Christmas Eve. But you're going to be seeing this on the Friday after Christmas. So Merry Christmas to everybody. Yes, Merry Christmas. I'm sorry if you're offended by that. Yep, we say Merry Christmas in this household. But I still love everybody. I don't care what you celebrate. If you're celebrating, you're having a good time, and it's all about what you do. You know what? Bless you to you, and I hope that you're having a good time. So hat challenge for last week was Venezia. And we're going to put a picture of the hat up there. I have a picture. Now, but you got to go back and watch the video. You can see the hat again. Now, Venezia is the Italian word for Venice. And yes, that's where the hat was from. And that was one of our trips we took to Italy. It was actually one of the very few guided tours that we took when we were there. We actually took a train from Rome, because we were staying in Rome for about 13 days. And from Rome, we would go to all different locations. So when we went up to, from Rome, we took a fast train. I don't know if it was fast, 4-hour ride to Venice. But the train systems there are amazing. You can go anywhere. I mean, you can go from Italy to London to Paris to Spain. I mean, all with these train systems. It's pretty awesome. So we took a day trip up into Venice, and absolutely gorgeous. Let's take a look at some of the pictures, and we'll have obviously some fun facts about Venice, Italy. But let's look at here's some pictures. Now, this is a picture that Heather and I actually took in one of the gondolas. You know, we were having a bad hair day, so probably not going to see any pictures of us, but this is an actual picture of us in the gondola in the little rivers. Now, the entire town of Venice, Italy, looks just like this. There are no drivable roads. I'll show you a picture here in a second. Let's go to the next one. So here This is us walking down the street. Now, all the streets in Venice, Italy look like this pretty much. Just stone streets like this, stores on either side, different restaurants. We had lunch and dinner at a couple amazing places, really good, real friendly people in this area. And over here on this side, now this isn't an actual picture that we took. For some reason, we were standing on a bridge and we did take a picture, but for some reason I can't find it. So this is another picture I got. But this is what it looks like. These are the bridges that are down the little rivers, and you have the gondolas all over the place. Just absolutely gorgeous. It was a beautiful day out, so it wasn't too horrible. And kind of a fun fact about the guys driving the gondolas. My understanding is you have to be basically born into something like that. Some foreigner can't just come over into Venice and decide to become a gondola driver. There's specific criteria that you have to do. But it was fun. We had a beautiful day and it was a good time. Now let's talk about the hat that I have on today. Now this hat is one of those hats. And now when Heather and I travel around, I mean, we've been to 43 states, all kinds of countries, there always seems to be a specific time where we have some type of dramatic adventure. Now, and when I say dramatic, most of the time it's not a good dramatic. Like when we were in Colorado Canyon City, Colorado, the whitewater rafting debacle that we had, where we flipped over and we got stuck under the raft, and we were moments away from death. And Heather and I, we talk about that. And in my book, I'm going to be talking about that. We have two different books. One is Wired for Success. You can see a picture of it up in here, which talks more about the business side. And the next book that I'm writing, which will take a little bit to come out, is called Falling in Love in 200 Square Foot. And it's about how my wife and I met. And for our first 4.5 years, we traveled in an RV while we were growing ProCalcs and traveled all across the country. And what amazing adventures we had. It was just, I mean, can you imagine meeting somebody, not even engaged to them yet, and wanting to live with that person in a little tiny 200 square foot place, 24 hours a day, 7 days a week. If you can put up with somebody like me like that long, you know that's somebody that you're gonna marry her, right? She's gonna be with you forever. So that's what this has about. So you can see if you can figure it out, what it says, and we'll talk on the next video about all the little details. Today's video is going to be about the issues we see when homes are being constructed. Now, you would think that because of all the regulations and the rules and the defined thing, that there shouldn't really be an issue. Most of these people are under a lot of pressure. They don't have a homeowner breathing over top of them. They have much more freedom. When I was in the industry and I was out doing new construction homes, there was a lot less pressure on you than going to a house that already had a system that was already installed. You had the homeowner, they're telling you the problems, and then you're having to try to figure things out. With new construction, most of the time, especially for some of these better companies, they have refined a process to get the system installed. And there's usually different time frames that certain things will happen. Different parts of the air conditioning system will be installed at different times in the construction process. For instance, if a house is on a slab, many times, depending on how everything's going to be run, the HVAC contractor will come out and actually put 4-inch PVC in the ground for where he will be running the refrigeration line through the concrete slab and through this 4-inch pipe, PVC pipe. So different things like that. Refrigeration lines will already be put in the ground, different things like that. But if these things aren't done properly, and other things we're going to discuss today aren't done properly, it creates issues that will stick with that system forever. And if the right HVAC company is not out there to diagnose the problem, they won't be thinking all the way back, oh, it's a brand new construction house, can't be anything wrong with it. It's a brand new system, it's brand new ductwork, it's brand new refrigeration lines. But is it? So that's what we're going to be talking about today. I'm going to try to keep some of it short, and then we'll put a lot more detail in the book that's going to be attached at the bottom. So let's dive into one of the first issues, which is what we've been talking about in a couple videos about oversizing your system. But this is the part when you're looking at new construction where it's the reason that actually a lot of the big builders that we work to came to us versus using their HVAC contractor to determine the size of the system. And it's like we talked about last week or the weeks before about 400 to 500 square foot per ton. And you got these HVAC contractors that even though they're doing new construction and they're supposed to be up to date on these big things or new things, is they're still stuck in the past with sizing and they're not doing it properly. Also with new construction, especially today, a lot of these builders like the Beazer Homes, the LGIs, the Lennars, the DR Hortons, just all these big builders, they are really pushing for energy efficiency. And the key to that is if I'm installing as a builder, I'm offering you the option for higher efficiency windows. And when I say higher efficiency, I'm talking about like the solar heat gain, which is the SHGC, and the U factor. And those two things, when we do a series on windows or a video on windows, we'll talk more in depth about that. But basically, the better the window means the less the heat is going to directly come through that window, which is the solar heat gain. And the U factor is what helps to stop the heat from penetrating through as quickly. So it's better insulation. So you have double pane, triple pane windows, you have low E, you have argon filled, air filled. There's just so many different options. But if the builders are investing in better windows, obviously the price of the house will be slightly more. But if these HVAC contractors are not taking this into account, it could make the difference between a 3-ton and a 5-ton all day long just because of the windows. That's key. So oversizing, big issue. Let's go on to the next one. And hey, don't forget, if you like what we're talking about so far, don't forget to do the thumbs up, subscribe, ring that bell for us with all notifications. We've got these coming to you every Friday, and we're going to have more coming to you later on about business and doing some podcast videos on YouTube from different companies like AeroSeal that'll be coming up, which is an amazing product. So the next one is talking about incorrect ductwork design. And I'm gonna go over here to our RightSoft software real quick. Now, when I say duct design, years ago when I worked for a company, the way I was taught by them was we would walk around with a tape measure and we would measure the square foot of the room. And then they would have this rule of thumb formula that based on the square footage of the room, that would be the size of the duct that would go in that room. Okay? Not taking anything else into consideration. What direction does that room face? How many windows? What are other potential issues in that room? Like for instance here, if I measure the kitchen and the kitchen comes out the same thing as the master bedroom, and I put the same size duct in the kitchen as I do the master bedroom, that kitchen is going to be hot as can be. Why? Because as we talked about last week, there's all these different heat loads in the kitchen. There's the stove and refrigerator and little appliances and all these different things that have to come into factor. So when we do a design and we do it in the software, RightSoft software, before we enter the type of system we're looking to use, the software is going to spit out how many BTUs that room is creating based on the walls, the windows, appliances, or whatever in that room, occupants. And based on that, it's going to determine how many CFMs, cubic feet per minute, that room needs to properly circulate that air. All right. So then once we put the system we're going to use by using a manual S selection software, then it's going to calculate based on what it needs and based on what the system availability to put it out can do. So in this instance, once we selected the equipment that we're using, so here's in RightSoft, this shows the equipment. We have a heat pump, and here's the equipment that this unit specifically has, and it breaks all the details down. Again, don't want to get into too complexity, but this is how it's just, and then it shows the amount of CFMs that the fan is going to put out. And based on that, it'll then go and distribute the air accordingly based on what the load requirements are. But let's look at something. If I determine that this bedroom is 167 square foot, it's got 124 CFMs, but now I come down to this bedroom, which is 119, not a huge difference, right? But look at, this is only 78 CFMs, cubic feet per minute. This is 124, okay? That's quite a bit difference. Well, what is the difference? Well, the difference is you got more windows here. It's facing different directions, facing south direction. You can tell by the compass. So all these things come into play with the duct system. So when you're designing a duct system, you're typically going to have, let's say this is a flex duct system, which that's typically what's installed in Florida. Can't get away with it much. This here would be the rigid, the fiberglass duct that comes off. And then we would branch out with the flex duct systems into branch boxes or whatnot. And the issue that we run into, and I know this from being taught this years ago, is when we size that room and we say, okay, that room's 127 square foot, we're going to put 127 CFMs in there. Then all of a sudden we have these rulers in the field that tell us that, well, with 127 CFMs, that's a 7-inch duct. Okay, using they call it a ductulator and other tools, it'll kind of give you a test. Now, using this software, which has a manual D process in it, it tells us what the size of that duct should be. And what it does is more than just the rulers. It looks at a lot of different factors. It looks at the velocity of the air, how long the duct is. You know, each of these transitions, like when this transitions into a grill, creates a restriction. So all these little things come into play to say, well, wait a minute, maybe a 7-inch duct, because the run is only 4 foot long, is too big, because what it'll do is it'll put too much air through that 7-inch duct because it's only a short period of distance. There's very little restriction. As the air is coming off, it's branching into that, so there's not a lot of restrictions with bends and loops and whatnot. So the software, when you do a manual D, calculates all this stuff into play to make sure that we're sizing properly. However, here's the other issue. It's just because I think a 7-inch duct should have 127 CFMs and the system tells me that this duct is going to put out 124 CFMs out of that, that's not necessarily the case. That's why dampers in the supply, me personally, I like return dampers as well. I know I'll get a lot of pushback on that, but if you want a slight positive and a positive pressure in a room, and you have a return that's not regulated, if I have 124 CFMs coming in, I need to be able to regulate that there's 120 CFMs coming out of the return so that I'm slightly positive. But if I just let an open 7-inch duct and I let an open 12-inch return duct in there without having the ability to regulate it with a damper, then I'm like a broken clock. I might be right twice a day. And that's not what it is. So dampers are extremely important. They're actually mandatory if you're actually following the manual D duct design rules. But you'll probably find that less than 10% of builders and HVAC contractors out there put dampers in their duct systems. Okay, so they have to be designed and installed. So when we design this, there's all these clarifications that come into play that this duct has to be run with very minimal restrictions. It's a certain length. Well, if somebody doesn't design this the way we have, but they still use the same duct sizes in the rooms, if they create a lot more restrictions in the duct system by the time they install it, then our design is null and void, because now there's an extra restriction in this kitchen maybe. So your kitchen's supposed to have 2 grills at about 105, but if they don't install these properly, then they could get a lot less than that. And if they're not dampering, it could be even worse, or it could be too much air. So that's where the importance of proper duct design, proper air distribution is extremely important. The next thing that's a big issue is the refrigerant charge. Okay, now charge refrigerant. Let's go back over here to our picture. This is just kind of a quick mock-up of what you have your refrigeration gauges over here going into the units on the low pressure and the high pressure sides to charge the system. And the manufacturer comes with its own guidelines. It says based on so many feet of refrigerant, these should be, they have subcool and superheat depending on how you're charging the system. Also weighing the amount of refrigerant that goes into the system is very important. But what happens is they install the refrigeration lines. Let's just use an example. They install them in the slab underground. They tape them off, which is typically what a lot of them do. They got an open copper pipe and they just put some tape on it thinking it's going to protect it from stuff. Now, they come back out when it's time to set the condenser outside, and they come out and they pull the tape off, and maybe they'll clean the edge a little bit, and then they'll just start soldering it into the closed refrigeration system. All right, not knowing that maybe dirt and dust and rocks and debris got up inside that line. I'm talking bigger stuff. So what happens is then they put their gauges on it and they do what's called a vacuum. So a vacuum is a machine that pulls the air inside the refrigeration lines down to below atmospheric pressure. And when it's below atmospheric pressure, anything that's called a non-condensable would just basically evaporate off. So if there's any moisture, whatnot in there, it would evaporate into the system. But we're not talking about big dust particles and small rocks and things like that could have gotten in. If they stay in the system, they are going to cause problems. So making sure that they're flushing those out so that when it is time to charge, it is a very clean refrigeration line. Okay, it's important. Now, when they charge it properly, the manufacturer is going to say 15 feet, but they need to look at the subcool and superheat when they're charging and then know how much refrigerant length they have. Is it 50 feet, 60 feet? And then using, depending on that system, if they're weighing the refrigerant, some of the newer systems like Train has a system that has its own monitoring. But then again, it's like using a calculator. If you use a calculator, you start to forget how to run those numbers in your head and you get complacent. So somebody goes out there, pushes a button, and the red light says, oh, yep, I'm charged properly, with somebody not actually being able to verify that that technology is functioning. So it's very precise. All the manufacturers have their specific charging requirements. Everybody is different. Subcool and superheat are some of your more constant terms. And, for your technical people, when I do the book that's attached to this, there will be information, more detailed information in there about subcool and superheat. If you're a nerd and you like that stuff, which I'm seeing from the comments, I'm seeing that there are some people out there that are really engaging with us in the comments and learning some stuff. So hopefully the books will help those type of people that like that. So refrigerant charging, this thing is inadequate air sealing and insulation. And what I mean by that, we kind of talked about this last week in the video. But what I'm talking about is here's ductwork that's in the attic. Now, this is metal round ductwork, and you really won't see that much in Florida, except in some really, really old homes where they used to use that. Now, flexible duct is the key, is what they're using. But you can see all this tape breaking off, the insulation coming off, which means as the air goes through this over here where it's insulated, but when it hits this, it's got no insulation, it's got a leak, it's going to pick up a lot of heat. It's going to bring in a lot of attic heat. See, this is a really tight attic. I mean, you can see the pitch of this roof. I mean, you're lucky if this is, I don't know, probably a 212 or a 312, if that. So very tiny, not a lot of space. It's an open attic, which means that that there's air from the outside getting into this area, and probably doesn't have a lot of insulation in the ceiling. But these are things that need to be considered. Are they sealed properly? Something like this probably just needs to be replaced because of how bad a shape and condition it's in. You would spend more time and money trying to fix this than just install a new flexible duct system. So very, very important that everything is taped off. Back to what we talked about last week with sealing and cleaning and making sure that the duct system is like, it's almost, kind of like your veins, and the air is the blood. The system, your heart's pushing the air through the system. the air handler is pushing it through the system, and it's getting it to the vanes, which are the ductwork, and then that's getting out into all the components that it needs, all the different parts of the body, or the parts of your home, the rooms and whatnot. So very important that we have this designed properly, that it's installed properly, that it's sealed properly. Next thing is thermostat placement. Let's see if I have a picture of thermostat placement. Nope. Here's another picture created with showing leaky ducts. Have all these little tiny spaces and things of that nature that the air is leaking out of. It can create an issue. The other thing I wanted to point out here was this happens a lot. You see how this insulation is scattered? Make sure my cursor is scattered all around the floor and it's not consistent. That's another big problem, because if the insulation is inconsistent where it is in the attic, the problem is you're going to have hot spots in the ceiling, and it could cause issues with hot and cold spots in the rooms below those. So having a nice consistent layer of insulation, whether it's blown in or bad insulation, whatever it is, making sure that it's consistent all the way across is real important. But thermostat placement. I had a picture of a thermostat placement, and I'll show it to you here in just a second. But the key is the code calls for them to be between 48 and 60 inches. Now, usually about 54 to 55 inches is kind of a standard thing that we would tell our installers. But here's the key to making sure that the thermostat is in the right place. Okay, now we're talking about the thermostat and the placement. Let's go back to one of our pictures and let's show them. Okay, so here is a thermostat on a wall, but here's something that has to be considered. When you're placing the thermostat one should be close to the main return that the air is going in, so it can properly determine the temperature of the air going into the unit and keep it consistent. Because if you have the thermostat in a location it's got a lot of heat bearing on it, like you see here, we got sunlight coming in from that window shining right on that thermostat. Now, even if that thermostat is directly under the return, the temperature, the sun and the rays are actually going to increase the air temperature in front of that thermostat, and it's going to make the thermostat think that it's hotter than it actually is, which could cause the unit to run longer and cool the house down in certain areas lower than it should be. So very important that thermostats should be on an inside wall, not a wall adjacent to a garage or any other kind of outside source. It should not be adjacent to any windows where you see sunlight coming in that can affect it. It also should not be in kitchens or by kitchens or by laundry rooms where there's any dramatic heat sources. So very, very important that the HVAC company place it in the right spot so that there's no heat coming from behind it, on the sides of it. Otherwise, it's not going to function properly. And we see this a lot in people not knowing where the thermostat, just somebody told them, but because the house was built slightly different, their interpretation, not knowing the code or the real rule about it, they just installed someplace that it shouldn't be. Or a renovation to a house and the HVAC contractor just leaves the thermostat where it is, even though it wasn't in the right place to begin with. So these little things all make a difference, and they happen so frequently in new construction. One of the other things that we'll talk about here is building codes. All right, so building codes, very important. Building codes are easy for you as a homeowner or somebody who's in the business to find. They're free to everybody, okay? And it's so misunderused by, I guarantee you most HVAC contractors have no clue where this is, how to look at it, or where to find it. They just know that the local building department fails them so many times over certain things, they have learned to overcome them just because of them failing, not actually looking up the codes. I mean, we have people come to us at ProCalcs all the time that are HVAC contractors, maybe some builders and whatnot, that have absolutely no clue of the codes. So real quick, I'm going to show this. This is the codes. You can put that. Well, actually, Maria will put this in the chat below. But we go in here, we can show locations. You can find the state that you live in, and when you go to the state that you live in, It has all the different codes that are set up for that state. One that we're in a lot is this one right here, energy conservation, which is very important. It talks about the type of windows that are mandatory. It talks about the mandatory insulation and walls, how thick they have to be. Talk about the building codes if you're renovating down here, existing buildings. And this is all free. You can open this up and look at it. Like if we're looking at the energy code and I click on that, if I'm doing commercial, I know I can look down here in commercial. But if I'm looking at residential, I know that I would come into some residential stuff and I would look at the codes requirement for that. Like right here, this is the one we play around in a lot. Okay. And you click on this and this is all free information. Then some of it might be dramatic and, and you might be like falling asleep reading it, but there are some good sections in this that can be really beneficial to you as a homeowner if you're thinking of building your house or renovating your house, or if you're an architect, a builder, and an HVAC contractor. This is the place to go to learn about the things that you should know in your business. And the last one is, so we don't make this video too long, is maintenance. Regular maintenance on your system. That is key, is even though it's not part of the installation, it really helps you. And my recommendation, just me personally, is I would avoid the person who originally installed the system to do your maintenance. And because if I'm the same air conditioning company and my friend John is the one who installed it and I'm the service technician Tom coming out and John messed up, do you think I'm going to tell the homeowner, oh, this is a problem, this is wrong? I'm going to go back at John. John, man, you should have seen it. And most likely it's not going to get fixed because John doesn't want to swallow his ego and admit that he did something wrong. So use a third-party company, let them come in, another HVAC company that you like, that you're happy with, that you vetted them properly, and let them look at it. But when they're coming out to do the maintenance, it's not just to maintain things, it's to help foresee potential problems that could happen in the future and taking care of them before they happen. Okay, so I've talked a lot in this video about stuff. We're going to go into more things as the weeks go on. Again, don't forget to put your comments down below about what we talked about. Tell us about the books that you see, if we could add more value to them. Don't forget to smash that like button again and subscribe to our channel so that every Friday when we get these things out, you get that little notification. Hey, it's time to learn some more stuff from ProCalcs University. Two things before I go. One thing, I have this background that I like to talk from, and then I have this background that I like to talk from. Which background do you like best? Put it in the comments down below. This is actually my computer screen that's in front of me. I have it as a picture in the background, but this is my actual, I've talked about this before. I just love the setup. I love to be able to do multiple things at one time without having to flip around. All right, so really good stuff, and I appreciate it. Just let us know in the comments below. And remember, you can teach the right person anything. You can't teach the wrong person anything. Are you the right person?